Hello, and welcome to today's lesson where we're going to explore two more congruence shortcuts so we can really fill out our full gamut of possible shortcuts to prove congruence besides having all angles and all sides given to us. Okay, so now we're looking at all of the possible shortcuts there can be, and we want to know what works and what doesn't. Now, based on our last lesson, we know that side works. We know that side angle side works. Now, there's some that we know that don't work based on our last lesson. We know that angle side does not work, and its counterpart side angle does not work. So far we know that in this picture, the first two work, the next two don't work, and what we're going to look at today is investigate these last four possibilities and see what works and what doesn't. Okay, now, when I look at these two triangles down below, okay, we know that all of their side lengths are the same. So if we go back to some of our previous units, I also know that all of these angles are the same. Okay, so now notice that the two triangles, the side lengths are different. They have different tick marks on each one, but the angles are all the same. So this is already going to help us get rid of one of our four remaining situations. And what we know based on this diagram alone, two equilateral triangles with different side lengths, is the fact that the angle congruence does not work to prove that two triangles are congruent. We know that they're similar, so we can do proportional sides, but we do not know that they are basically the same triangle or congruent triangles. Okay, so now we've got three left. We can see that these two are actually the same thing, just different order as you work around the triangle. So we're going to investigate these last two and see if they work to include them with the first two that we had from our last lesson. So now, angle side angle congruence conjecture. If two angles and the included side of one triangle are congruent to the two angles and included side of the other triangle, then the triangles are congruent. Okay, and why does this work? So let's look at our triangles that we have here. When we look at these triangles, okay, we've locked in the angles. So what we know is those angles are locked in. This side length in the middle is locked in. Okay, now what's not locked in is this side and this side. Okay, those side lengths are not locked in based on what we're given. But what happens is, since this side is locked in distance-wise, we know where these two angles start. And since we know that the angles are locked in, okay, even though these two sides could go on forever, there is only one place that they can meet based on the fact that the angles are locked in and that included, and that's always the important part, the included side is locked in. So you can see as I go counterclockwise around this, I've got an A, an S, and an A. All of those pieces are locked in. So what that tells us is those points are locked into each other. And with this one, it's A, S, A as we match the pieces, and we can work our way around. Okay, so that is one of our congruence possibilities, is angle side angle congruence. Okay, now The last one that we have, and we need to try to prove, is angle, our side angle angle. Okay, notice how this one's named. The side is not included in the angles. But what we know is we know that this side length is locked in. Okay, so this length can change, and this length can change. Okay, those are pieces that are not locked in. Okay, but the problem here, and this is not the problem, this is actually the good situation. The good situation here is since this is locked in, if I try to move these sides out, this point won't connect anymore. If I try to stretch this side, they won't connect anymore at that point. So what happens is by having the two angles that we could slide in and out match up with a locked in distance, okay, it does make the triangles congruent. Okay, so if we look at our pieces here, we have an angle, and we have a ticked mark side. Okay, remember, as you go around, you can't skip any more than one piece. So I'm going from angle to angle. Okay, I did skip over the side, and then the next thing I go to is the side. So in this one, it would be an angle, angle, side. Now, if you happen to go the other direction, which is okay, I've got a side, and I go to an angle, and from an angle, I skip over only one piece, okay, which is okay. And so I go from a side to an angle to an angle. Okay, either one of these works for a congruence statement. Okay, so what we've done is in looking at these triangles, we've helped prove the angle, angle, side, or side angle, angle, and the angle, side, angle congruence conjecture. Okay, so now what we have is we have 4 different types of conjectures that work. Okay, all of these work. Side, 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 angle, side, angle, side, angle, side, angle, angle, side. Okay, notice with angle, side, angle, side, angle, side, it's always an included piece. You have 2 sides and the angle in between them, or 2 angles and the side in between. The one that's really different is the side angle angle. And just remember, you can skip over one piece, but you can't skip over more than one piece when you're trying to name the triangles. Okay, now, which types of congruence don't work? Okay, we saw that angle, angle, angle doesn't work. And then we know that angle, side, side doesn't work, okay, which is also known as side, side, angle. Okay, and you know, the one shortcut we have is, okay, you don't want to say any bad words when you're making your congruent statements. So now, let's look at a few examples, see what we can prove, and if it doesn't work, we'll say that it cannot be determined. That's what CBD stands for. Cannot be determined based on what we have. Okay, so now, what do we know right off the bat? We know that angle AEB is congruent to angle CDB. Remember, you have to name them in the correct order. Okay, and that's something that's given to us. So we're given an angle and an angle. Okay, based on tick marks, we also know about sides. We know that EB is congruent to DB. Okay, so there's a side. Here is, got that backwards. Here is an angle. Here's a side as we're working around the triangle. And then we always have to look for things that are given but not marked. And we do have a piece here that is given but not marked. And it's the fact that this angle and this angle are congruent to each other because they are vertical pairs, vertical angles. Okay, so angle ABE is congruent to angle CBD. Okay, and we know that based on the vertical pair, and I should actually give that a different tick mark measurement. So then that is another angle. Okay, so once again, following our rule, we have three pieces. Now, is it a good three pieces that we have? Okay, we want to follow around the triangle from one piece to another. Remember, we can't skip more than one other piece. In this case, we're not skipping anything. We've got an angle, the side in between, and the other angle. Okay, so this is angle, side, angle, congruent. Okay, that's one of our four main congruent statements. Okay, now, looking at this one. Okay, looking to prove congruence again. Okay, I'll go a little bit faster through this one so we can get through and get you to the work. Okay, we can see that this angle and this angle are congruent based on tick marks. We know that this angle and this angle are congruent based on tick marks. And then we're always looking for those hidden pieces. We have a hidden piece here. Take a second and see if you can find what is the hidden piece. Okay, the hidden piece is the shared side between those two pieces. Okay, so now when we look at what we have an angle. We're skipping over the side to get to the next angle. That's okay. And then from this angle, we go right to a side. So in this case, we have angle, angle, side. Okay, we didn't spell a bad word. Okay, so we're good there. And we know that these are congruent triangles because AAS is one of our four main conjectures. Okay, now, last one for today. Okay, are these triangles congruent? Okay, once again, working off of what we know. We know that this side and this side are congruent based on tick marks. We know that this angle and this angle are congruent based on tick marks. And we know that they share this side in the middle. So I can put a tick mark there and we have a shared side based on what we call the reflexive property. And then once again, we're just working our way around the triangle. Now, notice I can't work this way around because I'm skipping too many pieces. I'm going from a side, I would skip an angle, I would skip a side, I would skip an angle to get to this next side. So I can't go in that direction to name this congruence because I skipped over too many pieces. Remember, all you can skip over is one piece. So now in this case, I have a side. The next thing I come to is the angle. And as I work my way around, the next thing I come to again is the side. So are these congruent? Yes, they are side, angle, side congruent. Okay, now, is there another way to prove that these are congruent? And there is, if we think back to our similarity. Okay, I've got an angle bisector. That's what AC is. AC is an angle bisector. Since AD and AB are the same length, I now know that DC is the same length as CB. Okay, remember proportional ratios in triangles when we have an angle bisector, and then I would have a shared side. Okay, so I could use a different idea there to be able to work through and prove, and we could end up proving that these are side, side, side congruence. Okay, it would take a little bit more because I would have to go through those steps of the equal proportions to know that DC and CB are equal to each other, but that is something that we can use to prove in those situations. Okay, so that is the end of our lesson for today, where we investigated angle-side angle congruence and angle-angle side congruence. Thank you and have a good day.